Okay, video ni kita nak tengok what are the characteristics of chain reactions. So basically, chain reactions, it needs initiators, it needs scavengers, and it has wall termination reaction. So kita tengok slide seterusnya. Generally, the characteristics of chain reactions, it depends on temperature. And the type of temperature it depends on is very large. Okay, this is the first general characteristics. And secondly, it is very sensitive to trace or to impurities, or even it is in trace form of impurities, because it can alter the initiation and termination rates. And the other thing is, if we intentionally put the initiators and scavengers on chain reactions, so initiators basically it's a promoter, and for instance is scavenger. It has large influence on chain reactions. Okay, kita tengok the case whereby initiator is purposely put in a chain reaction. So as told before that one of the steps of chain reaction is initiation. So kalau generic equation the initiation step dia begini kan, in which that the number of molecules of A to propagate and to produce radicals. So this is at the initiation step. But if the initiator is intentionally put at the initiation steps, it will form radicals immediately. So this is the chemical equation, and this would be the reaction rate, in which that initiator to produce radicals, and the reaction rate would be rate constant of initiation times concentration of initiator. Okay, the same thing for scavengers. Scavengers, another name is poison. Let's say kita letak purposely the poison into termination step. So kalau by naturally the radicals dekat termination steps, naturally the radicals will be terminated and produce small amount of product X, and this is the rate reaction kan. Tapi kalau kita purposely letak scavenger dekat termination reaction, so F it reacts with R to produce the amount of X. So this is the rate reaction there with respect to concentration of radicals and also scavengers. So it is stated here that X is important in determining overall reaction rate. Alright, another characteristic of chain reaction is the reaction happens on the surface. Therefore, wall of reactor may one of the factors that can terminate the chain reaction, that can stop that chain reaction using the termination steps. I'm sorry if it is so noisy. Is it noisy? Okay. So surface reaction steps is important in controlling the chain reactions. And wall termination reactions would introduce the complexity to chain reactions, in which the overall reaction rate would depend on the size of the reactor. So in a small reactor, termination reactions on surface keep the radical intermediate small, and it can inhibit chain reactions, so the termination would happen. If in large reactor, the termination rate would be small. So what do you think is going to happen? Right? So you can answer on your own, but of course, I will give the answer. If the termination rate is small, So of course the propagation steps getting more, and the chain reaction is still on, so it's not going to be terminated. Okay, uh, the let's have a look at the example of wall termination step. Contohnya berlaku reaction pada sebuah reaktor yang besar dan memerlukan scavengers to be added to radicals in order to make the termination step to happen. So the step here, so you add the scavengers to the radicals, so it will produce a product. So meaning that this is the termination step that happens. So if the surface is really big, the surface reaction is really large, so the step of termination is controlled by mass transfer. Therefore, you have to apply the equation of this, which is already been introduced before, in which that the rate of termination would base on the mass transfer rate. So it has to be area over volume of that surface reaction that covered by scavengers times the rate of termination step with respect to the radicals. Alright, but still you have to take into account the mass transfer rate constant here, in which that this is the concentration of radicals at bulk minus the concentration of radicals on the surface. And you have to calculate of the rate constant of termination, which using this mass transfer coefficient and Sherwood and diffusivity, etc., etc. All right. So this is it. This is just the example on how to calculate the wall termination reaction.